3, we are now going to solve systems by elimination. Now, so far we've solved systems using graphing and substitution. So graphing was when we graphed both lines. Substitution was algebraically, where you plugged one value in for another. These notes today show you how to solve the system algebraically using elimination by adding or multiplication and then addition. Okay, so sometimes it's easier for us to just add, sometimes we have to multiply first before we add. Now, elimination is easiest when the equations are in standard form. What is standard form? Yes, ax plus by equals c. Okay, when they are in standard form, elimination is easiest. All right, so, next. When we solve by elimination, first you want to put the equations in standard form, so that's in your ax plus by equals c. Next, determine which variable we need to eliminate. Now, we look for variables that have the same coefficient, or if you add or subtract is one variable eliminated, that's what you want to look for. So for example, if you have, maybe not, 2x plus 3y equals 4, negative 2x plus 5y equals 6, right there the 2x and the negative 2x would cancel. Okay, I'll show you on the next slide what I mean. Next, you would add or subtract and solve for the variable. Then you plug back in. That's the same as the last topic too. Once you have one variable, you plug it back in to find the other, and you check into both equations. Okay, so let's see what this looks like. All right, this one right here, we have x plus y equals 5, 3x minus y equals 7. If we straight just add, x plus 3x is 4x, y plus negative y, that's 0. Y is eliminated. 5 plus 7 is 12. Now we have an equation in terms of one variable we can solve. 4 times x is 12, so divide by 4, we get x equals 3. From there you take that, take one of your equations. If x is 3, 3 plus y is 5, minus the 3, we get y equals 2. So we have the point 3, 2. Okay. Then we take our equations, 3x minus y equals 7, and x plus y equals 5. 3 times 3 minus 2, 3 times 3 is 9, minus 2 is 7, so that checks. Okay, and the second one, x plus y, so 3 plus 2 is 5, that checks. So we have a solution. Okay, very simple there. When they're the exact same, just different signs. Plus and a negative, a positive and a negative will cancel each other out. Okay, now sometimes it doesn't always work that way. If we add here, 2x plus 2x is 4x. Y plus negative 3y is negative 2y. 4 plus negative 4 is 0. We still can't solve. So that didn't work. Okay, in that case, we might need to multiply by a negative. If we take our second equation and we multiply everything times negative 1, because if you multiply everything, it doesn't change the problem. First equation stays the same. Second equation becomes negative 2x. Negative 1 times negative 3y is plus 3y. And negative 1 times negative 4 is plus 4. Now when you add 2x plus negative 2x, they cancel, right? 2x minus 2x is 0. Y plus 3y is 4y, because it's 1y plus 3y. And 4 plus 4 is 8. That allows us to then divide by 4 and solve for y. Once you have y, go back to one of your equations, y is 2. So 2x plus 2 equals 4. Solve it, so minus the 2, and divide by 2, you get x equals 1. So we have the point 1, 2. Okay, go ahead and check that. All right, write your equations. And write your original, not what you multiplied by. Okay, write your original. So here, 2 times 1 plus 2. 2 times 1 is 2, plus 2 is 4, so that checks. In the second equation, 2 times 1 minus 3 times 2. 2 times 1 is 2, 3 times 2 is 6, 2 minus 6 is negative 4, and yes, that equals the negative 4, so it checks. Okay. So there's one where you can add, one where you have to multiply by negative 1 and then add. Okay. Here's another example. This example says line it up. What does that mean? Well, they're not lined up where they should be. Remember, the first step in solving back up here is get them in standard form. Okay, so looking at this one, the first one is not in standard form. I need to add my y back over. So I have 2x plus y equals 7, and then 4x plus y equals 5. If I add, is something eliminated? No, because they're both positive. Y plus y is 2y. So we need to multiply one of them by a negative 1. And here it doesn't matter which one you multiply by a negative 1. Okay? But if I leave the first one the same and multiply the second by negative 1, I have negative 4x minus y equals negative 5. Now when I add 2x plus negative 4x is negative 2x. Y plus negative y, that y is eliminated. 7 plus negative 5 is 2. Divide by negative 2, I get x equals negative 1. Okay. Now, if I take 4x plus y equals 5, 4 times negative 1 is negative 4. That's times negative 1. Negative 4 plus y equals 5. Add the 4, I get y equals 9. So my solution is the point negative 1, 9. As long as that works, of course. So, to check it, 2x equals 7 minus y, so 2 times negative 1 equals 7 minus 9. 2 times negative 1 is negative 2. 7 minus 9 is negative 2. That checks. Okay, the second one, 4x plus y equals 5. 4 times negative 1 is negative 4, plus 9, negative 4 plus 9 is 5. So that checks. Okay. So there you have 3 examples. Go ahead and try these 2. Okay, these you're either just going to add or multiply by a negative 1 first and then add, or you may have to line up. Okay, so go ahead and try these. And I'm going to stop this video. I don't want them to be too long, so I'm going to stop this here. There is a topic 3 part 2, so once you do these U-tries, find topic 3 part 2 and pick it up from there.